This question is from NEET 2024. Let me read out this question now. Arrange the following elements in increasing order of first ionization enthalpy. And the elements given are lithium, beryllium, boron, carbon and nitrogen. First, let me tell about what do you mean by ionization enthalpy or energy. It is the amount of energy required to remove the outermost electron from its valential electronic configuration. That is removing of an electron from its stable configuration like that. Okay. So whenever we remove the first electron from its configuration, then it will be termed as first ionization enthalpy. And if you remove the second electron from the configuration, then it will be second ionization enthalpy. And one more thing we should be knowing about this periodic trends here. When we move from left to right side of the periodic table, ionization enthalpy or energy, it is going to increases. And as we go down the group, ionization enthalpy is going to decreases. So for these elements, for the given elements, first I'll write the atomic number for this one. So for lithium, beryllium, boron, carbon, nitrogen, lithium atomic number 3, beryllium 4, boron 5, 6 and 7. So accordingly, actually here ionization enthalpy should increase for what it is. It should increase from left to right side of the periodic table, and hence nitrogen should have the highest first ionization enthalpy, then compared to carbon, then compared to boron, then compared to beryllium and then lithium. Accordingly, like this, according to whatever it has said. But we have to consider some more things here, that is the electronic configuration. But here this is not the answer. I am considering the answer as fourth one as the answer. That is nothing but, let me take this beryllium here and I'll write the electronic configuration with the atomic number 4. It is 1s2 and then it is 2s2. So with a 4 electron, it is 4. Then boron I'll take here with atomic number 5. So it will be 1s2, 2s2, 2p1. Okay. If you look at the outermost configuration here and configuration here. In case of beryllium, we have to remove one electron from fully filled 2s orbital. So it is becoming difficult to remove this one electron from the fully filled 2s orbital, then compared to this one electron from the p orbital removing from this boron is easier. Henceforth, ionization enthalpy, especially the first ionization enthalpy, for which one will be highest now? Beryllium will be highest then compared to boron. Even though the trend, periodic trend says that as we move from left to right side of the periodic table, ionization enthalpy increases. Hence, it should increase for boron. But due to the configuration of this beryllium and boron, this beryllium is going to have the highest first ionization enthalpy then compared to the what it is boron. Henceforth, the option for this answer is fourth one is the right answer for this given question. This question is from NEET 2025. Let me read out the question. The question is the type of statement type question here. Which of the following statements are true? So they have given us statements of 5 statements here, and among them we have to see which statement is true here. Let me read out the statement. The first statement is that unlike a gallium that has a very high melting point, whereas cesium has a very low melting point. And this statement is of course wrong, because gallium and cesium, okay, so I'll write here for the first statement, gallium and this cesium both are having a very low melting point of temperature. Here it is going to have a 303 Kelvin and for this it is 302 Kelvin. So they have a very low melting point. Both of them have a very low melting point. So the first statement, that is A statement, is wrong. Second statement, on the Pauling scale, the electronegativity value of nitrogen and chlorine are not same. But on Pauling scale, both this nitrogen and chlorine, so B statement, second statement, both this nitrogen and chlorine, they have the same electronegativity on Pauling scale of value 2 here. Okay. So this second statement is also wrong. Let me read out the third statement. That is argon and then potassium, chlorine ion, calcium 2+ ion, sulfide ion, are all isoelectronic species. The third statement is telling that these ions are the atom, they are the isoelectronic species. So in the previous question I have told that what do you mean by the isoelectronic species. There is nothing but the ion or any element or the molecule that contains the same number of electron is isoelectronic species. So let me check that one. So for the third statements, that is C, argon with the atomic number 18, so it contains 18 electron, and for potassium it is atomic number is 19 but plus charge is there, which means removal of one electron is taken place. So how many electrons in potassium? It is also 18. Then chlorine, it is having the 17 electron but one electron is added, so it is plus 1, it is again 18. And then here calcium 2 plus is there, it is having atomic number of 20 but plus 2 charge means removal of 2 charges, which is going to give 18 electrons. Sulfide, the sulfur is going to have the atomic number 16, minus 2 charge means plus 2, which is nothing but again 18. So all this argon, potassium ion, chlorine ion, calcium 2 plus ion, sulfide ion are all having 18 electrons in them, hence they are termed to be called as isoelectronic species. So this C statement is true one. Okay, then let me read out the fourth statement. The correct order of the first ionization enthalpy of sodium, magnesium, aluminium and silicon is, they have given the order here for ionization enthalpy, and for ionization enthalpy again when we move from left to right side of the periodic table, the first ionization enthalpy is going to increases. Here they have given sodium with the atomic number sodium, magnesium, aluminium, silicon, atomic number of 11, then 12, 13, 14. Okay, so of course this seems to be correct only according to the periodic trends, that is from moving left to the right side of the periodic table, silicon is the highest, then aluminium, like that. But here comes the thing is that we have to consider again electronic configuration. For what it is magnesium, I am taking the electronic configuration for magnesium, that is 1s2, 2s2, 2p6, okay, then it is 3s2. 12 no atomic number, so it is 2, 4, 10, 12 electrons are present. Then for aluminium I am writing the electronic configuration with atomic number 13, 1s2, 2s2, 2p6, right, 10, then it is 3s2, 12, then it is 3p1. Okay, so here ionization enthalpy, that is nothing but removal of the outermost electron. Removing the one electron from this aluminium from p orbital is easier than compared to the fully filled s orbital from the magnesium. Hence magnesium ionization enthalpy is greater than compared to aluminium. Henceforth this is not the series that has to be considered. It should be which one here? Highest ionization enthalpy is for silicon, then for what it is magnesium here, then for what it is aluminium, then comes as which one? Sodium, like this. Okay, so the ionization enthalpy will be considered like this, but this is the wrong order. So D is also the wrong statement here. Then consider the fifth statement. The atomic radius of cesium is greater than that of lithium and rubidium. So they are considering the atomic radius. When we move from top to the bottom of the periodic table, atomic radius, it is going to increases. As we move from left to the right of the periodic table, then the atomic radius is going to what it is decreases. So henceforth, so when we consider this one here, that is lithium is there, below lithium rubidium comes, and then comes is what it is cesium. So as we go down the grid, atomic radius increases, and henceforth this E is also the right statement. So from all these 5 statements, the true statements are A, this C and E. So accordingly the given option, from the given option, third one is the right answer, that is C and E are the true statements from the following.